All right, so find the radius of convergence and the interval of convergence. I'm interested now not in a series, but in a special type of series. This is a power series. All right?
Wait, which one are we doing?
Number 3.
Oh, yeah.
Yeah.
Sorry.
Mm-hmm. So the only test we haven't used yet is the ratio test, and that's your weapon of choice when it comes to power series, right? So this is technically a function of x, but for not all x will this converge, or not necessarily. So under what circumstances? So using the ratio test, I look at the limit of the absolute value of the ratio of consecutive terms. And in this case, I'd be looking at a quotient of 2 fractions. That is to say, 2 to the n over 2 to the n plus 1, e to the n plus 1, and x minus e to the n plus 1, all over 2 to the n, e to the n, x minus e to the n absolute value. Now, powers of 2 and powers of e are never going to be negative anyway.
Right.
So this is going to simplify nicely. Although depending on what x is, the base might be negative.
So that still needs to be an absolute value, right?
So on top I guess I'll show one more step. 2 to the n plus 1 over e to the n plus 1 times x minus e to the n plus 1 times, so this bottom fraction is going to be flipped. That's going to be e to the n over 2 to the n. And this over 1 is going to be flipped. So I end up with 1 over x minus e to the n. And so that means that since I have n plus 1 2's on top and n 2's on the bottom, that is to say I have one more 2 on top than I do on the bottom, I'm left with a 2, just 1 2. Likewise, I have one more e on the bottom than I do on the top. After everything cancels, you're left with 1 e on the bottom.
I got that.
Again, one more factor of x minus e on the top than there is on the bottom. Everything cancels and you're left with that. And if x is regarded as a constant, then this limit is actually independent of that, isn't it?
Yep.
So it is what it is. It's 2 over e times the absolute value of x minus e. And in order for this series, for this power series to converge, this would have to be
Less than 1.
less than 1. And so as an inequality, what we're basically saying is that x minus e must be less than e over 2. To restate that in terms of distance, it says that the distance that x is from e must be less than e over 2. On the number line, I'd be thinking, okay, well, if this is e right here, then x is a point on the number line whose distance from e is less than e over 2. So going a distance of e over 2, you can either go left or right.
Plus or minus.
So you're either going to be at e minus e over 2 or at e plus e over 2. All right? Which
I got that one.
Yeah.
Wrote that here.
Yeah.
Felt good about that.
Yeah. So that's the radius of convergence is e over 2. That's like the distance from the center to the edge. The interval of convergence could be that, but not necessarily.
Yeah, how do you, so like what's the best way to prove if the left and right bounds or whatever?
Yeah, so since the question is to find the actual interval of convergence, which is more specific, it means that I have to really figure out what's happening precisely. Out here, I know that the ratio test would be bigger than 1, But right here, it's just not, it's inconclusive. When the ratio test gives you a 1, who knows? So I consider each of these separately. So case 1, what if
You just plug it in.
x equals e minus e over 2? Right? Also known as, well, since 1 minus a half is a half, that's e over 2, right? So in this case...
Wait, what'd you just say? I'm sorry?
1 minus
Oh,
half.
yeah, okay, yeah.
Yeah, so I'm looking back now at this series, but now I'm going to replace x with that and see what happens. So now, in the event that x is that in particular, I end with 2 to the n, e to the n, and in the parentheses I have e over 2 minus e.
Minus e.
E over 2, I'll write it out. E over 2 minus e to the n, also known as well, 1/2 minus 1 is negative 1/2. So this is going to be negative e over 2 to the n power. I'm going to skip a step here. I'm just going to say
I'm sorry, I was writing stuff down. Can you just say it like I just didn't hear you?
It's okay.
You ain't gotta write it.
Yeah, for the benefit of those watching and on the internet, that.
Okay.
And this, whenever the base is negative, you can kind of split it up as negative 1 to the n and e over 2 to the n.
Okay.
Hello.
Sorry.
No worries.
Is this the test?
Something new.
No, it's a
We're just going over the test.
Do we have to?
It's out of 75. Number 3 had some difficulties that I wasn't anticipating, so yeah. But yeah, and that, once we get to this point, it's going to simplify pretty nicely, actually, right?
Yeah, both.
Yeah, T,
Yeah.
those cancel, these cancel. Just left with the negative 1 to the n. Right? So it ends up being.
Oh, we went over it.
No, we went over. Oh no, this is number 3.
So the series just simplifies down to that. Now it should be a little more straightforward whether or not this one converges.
No.
And it does not. Yeah. If n equals 0, you get a 1. But if n equals 1, you're actually taking 1 plus negative 1, which goes to 0. It goes 1, 0, 1, 0. So this diverges. I guess you could say by the divergence test, right? And so therefore, we do not want to include this point in the interval of convergence. But I do need to check that one too for full credit. If you just check that one and not that one, I can give you 24 out of 25, you know. So checking as well, e plus e over 2, also known as 3e over 2. Then the rest of this, you know, it's going to be pretty similar to what I just did, what I just done.
I didn't finish it. I just found the radius. I didn't put the actual. That's what I got. This.
Well,
13. I didn't put the ends. But I got.
Yeah, I got
So
it.
that's the radius.
so anyways, if you go through the similar type of algebra, I'm just going to skip some steps now. You know, I trust you can fill in the steps. If you go through do the arithmetic here, it'll be a positive e over 2. And the 2 in on bottom will cancel with the 2 on top, here and here. And you're going to end up with,
Just ones.
yep, 1, 2, 3, 4. You just keep getting bigger and bigger. So this one also diverges by the divergence test, right? So now I can safely say that the interval of convergence is e over 2 and 3e over 2. And I literally mean what I say, and I say what I mean. I'm saying that the endpoints are not part of the interval, right? And that's what it would take to full code on this one.
Is it the? Yeah.
Mhm.
Never mind.
So with that, the second question was the hardest one.
Wait, wouldn't it be negative e over 2?
Which one? Negative.
The interval
For which one?
for that problem? Yeah.
Well, because the center of the interval of convergence is e,
Yeah.
and the radius of convergence is e over 2.
Right.
So e minus plus or minus a half.
Oh yeah. Have.
You know. Yeah.
Why did I write this negative?